Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Helmi Aminullah bin Jalisun. Today I gonna to present about mini project MEC435, which the product is table lamp. Next we go to the organization chart. Our group being led by Muhammad Haris Asfar bin Azhari as project manager, which advising and monitor the flow of the project. Muhammad Faham bin Arifin as mechanical executive, which analyze the mechanical factor of the product chosen. Muhammad Faris bin Kamal as technical executive, which advising and suggesting group member about designing product in Katia. Myself, Muhammad Helmi Aminullah bin Jalisun as documentation executive, which checking and monitor the process documentation of the product. Next, the scope. The product is LED table lamp. For the modifying process, there are lots of process. First, we go with surface and shape design. Next, constraint parts of the product, assembly all parts, draft and assemble all model. Lastly, the product sketch. To keep our project on track, in week 9 to week 10, we study the product details. In week 10 to week 11, we construct our lecturer. In week 11 and week 12, we contribute parts to the group member. In week 12 to week 13, we make the parts assemble and drafting. In week 12 to week 13 to week 14, presentation of the product. And lastly, report submission. For reason choosing the product, first, table lamp consume too much space on the table. On the study table, there will be a laptop, book, phone holder, and stationery box. This consume too much space for study. In order to minimize the space consuming, we need to redesign the table lamp so it will be more efficient. Second, current existing design is expensive. This is due to the brand company patent the design, so the design become branded. With the branded design, therefore the product is expensive. Next, the other design is too simple. This make the product is not worth money to buy. By recreating, the design become more multifunction, therefore it will be worth money to buy.
Hi, I'm Faris. Now I'm going to continue to present about the product modifications. We added 3 extra functions to the original product. It was originally a normal table lamp which have one specific function, which is to provide light to the users whenever users are working at the table. The idea of our modification is that the table lamp will have more function other than giving light to the users. So we added a stationary storage, a few pen holder slot, and a phone holder slot to the table lamp. So this is how our original product before any adjustment were made. This is the base part of the table lamp. The base is the heaviest part of the table lamp, and it actually act as an anchor to the table lamp so that the table lamp will not fall over to the left side or to the right side. But we notice a flaw at the base design, which is it is not wide enough to provide stability to the table lamp, since the lamp is placed higher than the base, so it will be easy for the lamp to fall over to the right side or to the left side. So at the end of our modification, we are going to solve it and added some extra function as well. This is the design for our modifications that we made into the table name. As you can see, there's a rectangular shape here that will be the storage for the users items. For example, whenever users want to do their work at the table, they can put their stationery like erasers, sharpeners, rulers, or even highlighter into this particular space. Beside the rectangular space, we have an extra three holes. This one, three holes that will be the pen slot. The users don't have to worry about the pen falling over whenever they want to place the table lamp somewhere else, because the holes that we created is not entirely through the bottom. And then lastly, the phone holder. This is the slot where the user will put their phone. So as you can see, I am drawing imaginary phone right here. The user can choose to put their phone vertically or horizontally into it. The same as before, the user don't have to worry about the phone falling over because we add a stopper at the right side of the phone holder. At the early stage of designing the modifications onto the base, we decided that the phone holders will be facing the y-axis, parallel to the y-axis. As you can see, I drew the view from top. This is the base, this is the modifications. It was placed vertically onto the base. But later we discussed it among our group mates and decided to make it like this, where the modifications and the phone holders were placed horizontally onto the base. This is because whenever user put their table lamp horizontally in front of them, they will have more space at the front. And other than that, whenever they doing their work, they will able to see notifications from the phone screens. And also, a wider base means more stability to the product.
Assalamualaikum. My name is Muhammad Alfa. So for my turn, I'm going to explain about the complexities of the features. So for this subtopic, I'm going to explain about the tools and or icons in CATIA while we draw the product. So first of all, I'm going to explain about what tools are there in Sketch. So we usually use these three tabs in Sketch. First of all, there is tab name profile. In this profile we usually use the circle and these lines, straight lines. Secondly, I'm going usually use this second tab, which is constraint. This is for measure the dimension for our product, how much length is it, or the radius, or anything else. And the third one, we usually use the corner icon. Also we use here there are another one which is something like eraser, and the third one from the operation we use the mirror. I usually use this. I commonly use this. Okay, for the next slide, I'm going to explain about the tools in 3D section. So in this section, for the first step named sketch base pictures, we use tab icon, pocket icon, shaft icon, groove icon, and the slot icon. For the second tab named dress up pictures, we use edge fillet here and the shell. For the third tab named reference element, we use this point and plane icon. For the fourth tab named transformation features, we use this mirror icon, which is similar to the in sketch one, but as I said, it's for 3D. And And for the next icon, we use this regular pattern. We use this for our product because our product have that similar pattern. Okay, last but not least, the last tool that we use for this criteria is called helix. First of all, as we can see the drawing here, this is not our product but the prototype for me to explain the helix. So first of all, before doing helix, we put the point on the surface of the cylinder. This is because for helix, for the starting point of the helix. After that, we need to determine the axis of the helix. For this, I'm using the z-axis because the plane we use here is xy plane. After that, we can determine the pitch height, pitch, the length of the pitch, which is this length from here to here. We can determine that. Also, we can determine the height of the helix, which is from the starting point and until the length of the screw here. So, for example, if the screw is 5 m 5 millimeter, so we can use the height for 4 millimeter. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Farhan Berifin and I will explain about the finite element analysis of the product. So, what is finite element analysis? Finite element analysis is the process of simulating the behavior of a part or assembly under given conditions so that it can be assessed using the finite element method, or we can say FEM. FEA is used by engineers to help simulate physical phenomena and thereby reduce the need for physical prototypes, while allowing for the optimization of components as part of the design process of a project. This is the structure properties and the material of the product. Material we use is plastic. We use plastic because of the lightweight of the material and it is easy to process. And the Young modulus is 2.2 E plus 0.09 Newton meter squared, and the Poisson ratio is 0.38. Even though the Poisson ratio in the region of the soft material, it is still strong because of the density is 1200 kilogram meter cube. And the thermal expansion is 6.84 E005 K degree, and the yield strength is 0 Newton meter square. This is the FEA of the leg. We put 0.5 Newton load at the x-axis of the part, and as we can see, most of the part is blue region, which means that it has lower stress, but only at the part where we assemble the upper leg and the base have higher stress. And this is the FEA of the upper leg. This part we also put 0.5 Newton load x-axis, and as you can see that most of the middle of the part of the upper leg have higher stress. This is because that this part actually we combine with another part and screw both of the part, which means that the structure will be more stronger and not have high stress like this.